Okay, so today I'm going to show you how to add two numbers on an Altair 8800. We're going to be using the front panel, and we're going to be using add immediate. Instead of adding two memory locations, we're going to add one memory location to an immediate value. And I'll show you what I mean a bit later. Okay, so let's come up with some terms first. So we want to add two numbers, right? So let's come up with terms 1 and term 2. So let's say term 1 equals, well, see, this program is going to add a memory location, the contents of a memory location to an immediate, so we have to put in a memory location. Let's say that this term is going to be stored in address 020. So let's do address, $, right? 020. But remember, 020 is a low byte, so we also need a high byte. So we need 000 020. Okay, now let's say we need term 2. Term 2 is going to be the immediate. It will just be a plain value. For this program, let's do 1 plus 1, right? Okay, so if 1 plus 1, that means we need to add 1 to 1. So term 2 must be 0, 0, 1. Then we have to store the answer somewhere. So let's say answer equals, but this has to be a memory location because we need to store the answer to a memory location. Let's store it to the next bit of memory after term 1. So let's say it's address 000 022. Okay, now those are the terms. Now where's this program going to start? This program is going to start .org. .org shows where the location is going to start. It's going to start at the first byte of memory. The first byte of memory is 000. So let's do 000. And now we can write our program. First, what we want to do is we want to load term 1 into the accumulator. So that instruction is LDA. Let's load term 1. Next, we want to add an immediate to the accumulator. So we want to add immediate, that is ADI. And the term we want to add, the immediate term we want to add is term 2. So that'll add term 2 to the loaded term 1. And then we have the answer, so now we want to store it somewhere. So we want to store accumulator, STA. We want to store it to a memory location. That memory location is going to be answer. Store to ANS. After we're done, well, the program's done, so let's halt. And that is our program. Okay, now let's hand assemble this. Okay, we are all set to hand assemble this program. So first of all, we need to figure out where is this program going to start. Well, let's look at what we wrote down for org 000. So here we put 000. Okay. And what is the first instruction? It's LDA. Now, LDA in 8080 assembly is 072. Okay, and then term 1. Term 1 is 000020. But remember, it's low byte first, high byte second, so we have to put 020 000. Okay, next we want to do ADI, add immediate. And that opcode in 8080 assembly is 206. And let's add the immediate, which is term 2. And term 2 equals 1, 0, 0, 1. Okay, next we have store answer, store accumulator. Store accumulator's opcode is 062. 062. And then answer 000022. So low high byte will be 022000. Now that is 1, 2, 3, 4, 5, 6, 7, 8 bytes. Now let's go to the second row. Let's go to the 9th byte. And that instruction is a halt. That is just 166. Okay, so we have hand assembled our program. We are ready to toggle this into the Altair 8080. Okay, so first we got to turn this on. Okay, stop, reset. Okay, so now we are ready to put in our program. What is our first instruction? Our first instruction is in LDA, and we start at 000. LDA is 072, deposit, and then we're going to load the address 2020, and then the high byte 000. Next, we're going to add immediate, and add immediate is 306. 306. We're going to add 1. Okay. Next, we are going to store the result at 062. Deposit next, and store the result at 022000 or 000022. So 2022, deposit next, and then the high byte 000, deposit next. Yeah, this LED is a little flickery because I think it's twisted in there, but whatever, we'll live with it. And then the last instruction is a halt. That is 166. Let's deposit that. Yeah, this LED is a little wonky. I gotta pop this open and twist it, but I don't want to do that right now. Anyway, so that is the entire program. Now we have to put something into 020. 020. Examine. So there's some junk in here. Let's put 1. Deposit. And then put 0 in the high byte because we don't need the high byte. And then if we examine next, this is where our answer is going to be 022. Well, there's junk in here, so let's get rid of that right now. Let's just deposit nothing into it. And then let's deposit nothing into the next part. Okay. So now if we go to address 0, we can then check to make sure that our program is in there correctly. Yeah, I'll get that LED fixed. And it should be all there. Awesome. So we're ready to run. Let's reset and hit run. Now, don't freak out about all these LEDs coming on. This is what happens when you issue the halt command. So let's just reset. Because remember, we're still powered on, so we're not losing any information. And now you want to see our answer. Our answer to 1 plus 1. And the memory location is 022. 022. Let's look at that. Look at that. Binary 2. And then to just check, we can look at the next high byte, but there's nothing there because we have added 1 plus 1, which is 2. That's it. It's very easy. Next video, I will show you how to add 2 memory locations together, which is a bit more involved. But I hope this was helpful. And with this, you can start to do all sorts of crazy stuff. Thanks. See you in the next.